This video will discuss the introduction to systems architecture. In this chapter, you will learn to discuss the development of automated computing, describe the general capabilities of a computer, describe computer hardware components and their functions, and list down computer system classes and their distinguishing characteristics. Define the roles, functions, and economics of application and system software. Lastly, describe the components and functions of computer networks. Computer systems are complex combinations of hardware, software, and network components. The term system architecture describes the structure, interaction, and technology of the computer system, and it is a misnomer, however, because it implies a concern with only the static structural characteristics. So you will learn about the dynamic behavior of a computer system, that is, how its components interact as the computer's system operates. So this topic lays the foundation of the system's architecture and with a brief discussion of the major components and functions of hardware, software, and networks. Each of these components is described in detail in the later chapters. And we have here a simple definition of a computer is the any device that can accept numeric inputs, perform computational functions such as addition and subtraction, and communicate the results. So this definition captures a computer's basic functions, but it can also apply to people and simple devices such as calculators. These functions can be implemented by many methods and devices. For example, a modern computer might perform computation electronically using the transistors in a microprocessor, store data optically using a laser and an optical disc's reflective coating, and communicate with people by using a combination of electronics and mechanics, such as the mechanical part and electrical components of a printer. And some experimental computers have even used quantum physics to perform data storage and computation. Now, the mechanical implementation of a computer in the early mechanical computation devices were built to perform the repetitive mechanical or the mathematical calculations. So this is the most famous of these machines is the differences engine built by Charles Babbage in 1821. Okay, which is this figure. This is the difference engine of the Charles Babbage invention. So the computed algorithms moves gears and other mechanical components. Many other mechanical computation machines were developed well into the 20th century. Mechanical computers were used during the World War II to compute trajectory tables for naval guns and torpedoes. And the bookkeepers and the accountants used mechanical adding machines as late as the 1970s. So we have here the common element in all these computation devices is a mechanical representation of a mathematical calculation. So the mechanical computation has some inherent limitations and shortcomings, such as the complex design and construction, wear, broken down, for the breakdown and the maintenance of um, mechanical parts, and it limits on operating speed. So the automated computation with gears and other mechanical parts requires a complex set of components that must be designed, manufactured, and assembled to exacting specifications. So as the complexity of the computational function increases, the complexity of the mechanical device performing it also increases. Now we have here the electronic implementation. Much as the era of mechanical clocks give way to the era of electrical clocks. So the era of mechanical computation eventually gave way to electronic computers. The biggest impetus for the change to electronic computing devices came during the World War II. The military needed to solve many complex computational problems, such as the navigation and breaking enemy communication codes. So the mechanical devices of the time were simply too slow and unreliable. We have here the quantum computing that is currently the computer technology is based on the principles of the classical physics developed during the 17th through 20th centuries, including electronics, magnetism, and optics. These principles are based on mathematical rules, describing the behavior of matter that at a level of atoms, molecules, and larger units. So, this quantum physics describes the behavior of matter differently at a subatomic level. So, in modern digital computer, data is represented by a group of bits, each having a clearly defined binary physical state. For example, a bit value might be represented by a switch that's open or closed, or an atom with a positive or negative electrical charge. So each bit has two possible states representing the values 0 and 1, and each bit obeying the rules of physical or physics must represent 0 or 1.